Didn't see you there, shareholders. Are you looking to maximize your profit and increase your shareholding value? Well, I got something for you. I'm part of the Society of Civic Autonomous Machinery, aka SCAM, and we developed an insanely new revolutionary product that will completely increase your profit margins. Now that's something to be,
excited about. Well, we introduced to you the Scissor Jack Intention. The Scissor Jack Intention will be found all throughout assembly lines across the country, because that's when you use scissor jacks. Well, it has the requirements that it needs to lift 6 vertical inches off of the ground. So it needs to raise from the ceiling that distance, which is approximately the distance of this marker, this bottle, 6 inches of this, or half a foot. It also needs to be able to support a 2,000-pound load for 10 to the 6th amount of cycles, and it needs to have an adequate safety factor for all the different failure modes, namely bearing, buckling, axial, and tear out. Now, off to our tech team who will describe the fantastic model that made this.
Oh, hey, I hear you want to learn about optimization. In order to make the best scissor jack possible for you and your shareholders, we made an optimization model that can intake all kinds of things and give you the best scissor jack possible. The one we used is called FMinCon. It's in MATLAB. We chose to minimize the weight using it, but it also lets you use things like set constraints. So we set constraint ranges for safety factors. We also let it vary the geometry to get the best possible result. We had to create an analytical model to input that can analyze every aspect and every failure point of the scissor jack. The inputs it takes are material properties and an initial geometry guess. After it goes through the model, it'll output things like weight, vertical distance the load can travel, the crossbar length, the safety factors, and the failure loads. It'll also do cycles to failure, which is really important for creating a long-lasting, safe product. And I think that these results will knock your socks off.
Speaking of socks, our first iterations are out of this world. Clocking in at an impressive weight of 1.3 times 10 to the 39 pounds and a crossbar length of 80 million miles, and boasting an impressive number of cycles of about -1 million and a factor of safety for buckling for 5 times 10 to the 71st, this scissor jack is absolutely insane. Over here we have the diagram and the earth drawn to scale. So clearly this demonstrates that our optimization model for our first iteration was working. But you know what? It can be hard to fit this scissor jack in your factory. So we changed a few things, added some constraints, and came up with an even better model. This version, it's only 4 pounds, has an 8.57-inch crossbar length, can survive for that many number of cycles, and is adequately safe. Now, in case you're wondering, and you're thinking that we're trying to scam you, which we certainly wouldn't do at all, we've gone through some intense validation procedures to ensure that we have given you the best results.
So once we're in ANSYS, we're going to want to open space claim and create a new sketch plane on the XY axis, because anything other than the XY axis is ludicrous.
Logan,
What?
get to the point.
Oh, the pin was a doozy, and to analyze FEA is good.
Here at the Society of Civil Autonomous Machinery, we are dedicated to making sure our scissor jacks will never fail in their extensive use cases. We had using our amazing resources of an undergraduate machine design course in which we inserted 3 homework problems. We had them analyze a specific geometry of the scissor jack to be able to determine what the loads were, and we used these values to validate it against our model. We also had extensive experimental testing with 3 instances of failure to be able to validate it that way as well. And if that doesn't prove our point, to make things even better, we used Gaussian simulated error to be able to determine what the spread was on the outputs of our model and be able to determine the best safety factors so that our scissor jack will never fail. And that's it.